So in this episode of whatever my YouTube channel is, I'm going to be telling you about how a hot air balloon works. Now, some of you might be asking, hey, this isn't like your normal videos. Well, you'd be right. I'm doing this for homework, actually. So, buckle up. So, first thing is, does anyone remember the floating lanterns in Tangled? Yeah, you probably do. Well, the thing is with those lanterns, whenever they light the candle, it causes heat. Well, in terms of science, heat is just like energy. Now, when I went and turned on that lamp, it caused heat coming off the light bulb. You know what I'm talking about, like when you accidentally touch the light bulb. It's super hot. Well, that is the energy coming off the light. Well, the heat that you're actually feeling is excited particles. I say excited because it's energized. So, energy in terms of science. Sorry. Rewind that. Inside of hot air balloons, there is thousands and thousands of particles of air. So let's just say that in a regular hot air balloon, there are 9 particles. Okay, 9 particles, not that hard. So what happens is heat is added. And when the heat is added, energy is added. So when you add energy to those particles of air, they no longer want to be close to each other. It's kind of hard to prop up my phone here. So let's say there's an air particle here and an air particle here, alright? And they're relatively close together. Oh. Well, the thing is, when you start adding heat to those particles, they start getting energized and they move away. Well, that is known as less dense. You've probably heard before. Well, when that happens, the air outside of the balloon is still at the same temperature that the air originally was. It's why you see balloons normally at either the daytime or at night. The reason for that is, well, because if you were to try to heat up a hot air balloon during the day, it takes so much longer in order to get less dense air. Sorry for the hiccups. So what happens is when you have less dense air, instead, the air is going to want to... Anyway, before I fell off my bed, when the air is less dense, it wants to go up to a place where there's less density. It's not going to be somewhere there's a lot of crowded air. Just term I just now came up with. So what happens is that is mostly Charles' Law. Still don't know what his first name is. Anywho, Charles' Law is that when temperature and volume, when temperature is changed, volume changes. So let's say that in a hot air balloon I have a super, super high temperature. Well, that means that the volume of the volume, it airing up is going to be greater. If I turn that heat down, well, that volume's going to go smaller. It kind of makes sense, So our assignment in class was to make our own hot air balloons. Kind of like the floating lanterns that, once again, you saw in Tangled. I almost said Frozen. Frozen was a terrible movie. So originally, we had wax paper, straws, string, 4 candles, and tinfoil. And that's what we were supposed to make our hot air balloon out of. Thing is, ours, me and my partner Cal, that's what we were working on, we were trying to light the candles when all of a sudden it burst into flames almost immediately. That sucked. So then what happens is we decide, alright, next day comes along, we are going to get this done where it's going to be way awesome. So instead what we decided to use was a big trash bag The reason we chose to use that is because we figured, hey, that might give us more volume. And the reason we chose more volume is so that more hot air can get inside the bag, and that would cause it to rise easier. So when we went to make our different one, we lit it, and again that one caught on fire. But by that time we weren't allowed to keep going with the project, so instead we decided to go off of somebody else's design, which a lot of them in class were able to float. It was awesome. I really wish I got footage of that, because I'd post it on here, but I didn't. So for our first iteration of the lantern, we decided to go with a square shape, not a round cylinder. We decided that a square a square cube would work better because it would be able to hold a bunch more air. Unfortunately, like I said, it caught fire. So our second prototype 2, we decided to go with the bag like I just said. Well, the thing is, I went to light that, and the tape caught on fire, so we put it out and threw it away. And then the rest of it caught on fire. So the reason we changed it, I actually already stated. I'm reading off this paper here that we've got to do for this lab report. So any of my YouTube subscribers or regular video watchers are going to be really confused by this video. However, my chemistry teacher, Miss Six, will probably love it. And I think that's about it. I think I just covered everything. If you have any questions, please post them in the comments below. I'd be more than willing to explain anything about hot air balloons or lanterns or what the heck I just did in this video. Or why I made the decision to upload it to YouTube. Alright.